Are we expecting any more people if you have any idea? Okay, so I'll start. So a brief intro about me if you have not read through that long email. I'm Dheryta, working with Vinayak and Sanjit, and I am co-advised by Professor Sunit Roy. He is from University of Washington. I'm in 5th year of my PhD here. And this talk will be based on my experiences that I have gained with working with Wi-Fi driver codes. I won't go into depth of the codes if you are expecting that, because that becomes too boring. But I will be covering some important concepts that are required for any developer to dwell deeper into driver code modification. And I will begin with a general overview of how Linux systems work from the point of view of communications, and where exactly you need to fire commands or make changes to essentially see what is happening in the world. Okay? So, which is why the title is Opening Nuts and Bolts of Linux Wi-Fi Subsystem. So, why do I need to attend this talk? Why is it important? So I've listed down few questions that came to my mind when I started working in the domain of Wi-Fi. So what happens in the background when I connect to Wi-Fi? Essentially, how does my machine gets a connection where I can send data between two or more machines? How does a packet travels all the way from my application layer to operating system's kernel, then to the air, and it comes back to me, to my machine? And how can I modify the code to try on my own algorithms? So if I know that this is the problem, this is where I need to make any change, where exactly I should be modifying the code? So based on this, I arranged this talk. First, I'll give you a bird's eye view of what Linux Wi-Fi subsystem is, what kind of Wi-Fi drivers are available in market today, how could you work with code, getting the source code, compilation, kernel insertion, and what is the flow of code when a packet is being generated to the packet being sent. What are the important commands involved to get the stats, and finally I'll give you some important pointers where you can actually go to get some tutorials if you want to begin the driver code modification. So those who came late, we have some Atheros cards with us, the commands which I will be giving. If you have a Linux machine, you can actually take those cards and fire the commands to see what kind of output will be generated. So, I presume most of you must be aware of this. Can you tell me what it is?
7 layers.
7 layers of?
OS.
So, Wi-Fi sits here, MLME, Mac. So, what does MLME mean? You just know these are OSI layers. Right? So, that's okay. So, MLME is basically sublayer of MAC, which is logical link control, and MAC is medium access control. So, what does MAC do in your communication domain?
Provide a unique address to each physical layer.
That is MAC address. Right? MAC provides a unique identification address. That's okay. But what essentially MAC is much more than that. What essentially MAC does?
This one is collision, so transmitting from one point to the other, if there is a collision in between, it's the idea of the MAC layer does that, is also the collisions and eventually makes it possible that I will.
Yeah, quite close. So basically, MAC is a layer which has several algorithms that decide when a packet should be sent, how a packet should be sent. It decides if that sent packet, the transmission of that sent packet was successful or not. If it was not successful, then what can be done to make it successful? So that's what MAC does. Basically, it says think before you send. You wait, listen to the channel. If it is free, transmit it. If it is not free, wait for some random amount, then again try it. Okay? And if it failed in the last attempt, which is checked by a loss of acknowledgement, then reduce some physical layer rate, resend it, that might increase the probability of a successful transfer. So that's what MAC does. And MLME is subpart of MAC, which basically decides that how all these things should be managed, and in decoding world, this is where you would need to change most of your code to get your things working, which is MAC layer management entity. So what MLME does? Authentication, deauthentication, association, disassociation, reassociation, beacons and proofs. So, any idea of what is authentication and association process?
Basically enter the correct credentials, then it authenticate with them.
So, what are those credentials?
So I use Wi-Fi password.
Yes. So, basically, when you are trying to establish a connection, first thing that as a user you need to enter is the WPA PSK key or and different types of keys that we are supposed to enter. After that, you get associated. With that, you will not have an IP address yet. You will be associated on the MAC layer, and IP layer is above that, so you don't still have the IP address. So that's where this MLME layer helps. Okay, so it is still possible to communicate over MAC layer, though you don't have an IP address. So most of your phones also, even if you are connected over MAC and it does not have an IP, it says you are not connected, which is not true. You can actually try that out and see. Okay, you will be connected, you can still communicate, but you don't have the TCP/IP stack with you. That's the only thing. So how can you know about your Wi-Fi card? So this is the command which you fire. It will list what kind of wireless card you have. It not only wireless card, it will also list your Ethernet card. It will say what is the MAC address, what is the width, at what clock rate it is working, and what is the firmware, which driver version you are using, does it allow broadcast or not, what driver code it is using, and what driver version it is using. So this is a very important command for those who want to know essentially what are the details of my Wi-Fi card and which kind of driver do I need to install, and if a driver is installed or it is not installed. So if you want, you can actually shoot this command on your machine and see. This should work irrespective of your Atheros or Broadcom or whatever card you have. And sorry?
So this will only show the details of the Wi-Fi card.
Yes,
Also
the PCI card or so basically only your PCI card and the driver details. And I will be sharing this deck, so you don't need to make note of these things. It will be available publicly. Then the next important command is IWconfig. Once you are connected, maybe you don't have an IP yet, but when you are connected, you fire this command irrespective of the card, you will be able to see the details there. But this is an Atheros card, and where I have made driver modifications to give me most of the details. For example, transmission power, what is the frequency I am working on, what is the bit rate, if RTS CTS is allowed or not, power management is on or not, what is the signal level. So all the information that is being displayed here, you can actually compile your code to enable or disable the fields which are displayed here. So I have enabled all the fields, which is why I am getting all the information. You can see what is the link quality. Once you are connected and you move away from your access point, you can see this link quality degrading, signal level degrading, transmission power increasing, maybe if transmission power adaptation is enabled on your machine. Next level is, once you have got the IP address, then you fire ifconfig command to essentially see what is the IP address you have got, what is your MAC address. This should be same to what LSHW displayed, and all the details related to IP. Now, how many of you know what is a network manager? Did you know the things which are displayed here are actually network managers in your machine? Good. So, but because when I ask people what is a WPA supplicant or what is WICD or what is a network manager, people don't know what it is. So, in phones, you do not have a separate network manager. Specifically Android, the drivers which I have seen, they call it as WPA supplicant. So if you have to make changes in an Android phone, essentially you have to make changes to WPA supplicant. Whereas if you have to make changes in your Ubuntu machines, then you can change network manager also, you can change WICD also, and you can change WPA supplicant as well. But you need to check in the background, only one of them is running. Because if let's say if you start a network manager, it will start WPA supplicant by default in the background. And whatever changes you have done in your WPA supplicant or network manager, WPA supplicant will be doing something else in the background which you will not be able to identify until you see what is the background process. So make sure you do change in one code and disable all other codes to see what effect it is getting on the machine. So now we have two kinds of Wi-Fi devices: full MAC devices or hard MAC devices and soft MAC devices. Any idea what they are? No idea?
Maybe one could change back in the software one program had changed.
Yeah, that is suggested by the me. So basically, your MLNE code or MAC code, when it is done in the software, basically you can write the code, you can compile it, reinsert the modules, that is your soft MAC. And most of your Atheros chipsets are at soft MAC. Whereas, most of your phones are full MAC. That is because of the battery constraints and device constraints, size constraints and all those things. Right? So it is much more easier to change things in the soft MAC because you have control over rate control algorithms, you have control over the transmit power and whatnot. All the algorithms possible you can actually change in soft MAC. So we have these devices with us, lot of them. If you want, you can actually open the code, change, and the world is out there. Now, this is another important thing, that what your card is capable of operating. I have not listed the command here. The command is sudo iw list that displays what is the capability of your card. For example, I want to make my laptop as an access point. Okay, so is it even possible to do that or not? HostAPD is the code to make your laptop as access point. If it is possible or not, that you have to check first before doing all kinds of things and finding it out in the end after wasting 2 to 3 days that it is not possible. So first of all, check it. So P2P client and P2P Go is the ad hoc mode, Wi-Fi direct mode. Mesh point is again ad hoc. Monitor mode is to capture packets which are going in the air. Then access point and manage mode is the by default mode that we generally use. So this is another important slide which I would like to spend time with. So first of all, in user space you have applications, as I already said, WPA supplicant and network manager. After that starts the kernel space where you have all the MAC drivers sitting. And then you have device level drivers, and then you have physical layer here. Okay. Now these correspond to NN80211, CH80211 and MAC80211, and finally ATH9K, which was listed with LSHW-C network command. So these are the points where essentially you would want to make changes, and 90% of changes will be done in MAC80211, which is the MAC layer, MAC sublayer. Now how does the driver loading happens? First of all, your configuration command. So CFG is the configuration of your drivers. Then you have MAC80211 and then you have Atheros. So if you want to insert the module ATH9K, it won't be inserted until these dependent modules are inserted. So whenever you do a driver modification and you just say ATH9K is the module, it is not working, I don't know what is happening, this module order you will need to take care of. Only then you should be making only then you will be able to insert the changes of ATH9K which you have done. And the rest of it I will cover in the demo section. So if you want, you can try this on your machine also. So sudo tail -f varlog syslog is basically showing all the system log that is generated when you are inserting or removing a module in your machine. rm mode is the command which removes a driver. So this will basically emulate that a card is inserted and a card is plugged out of your machine. Okay? And mode probe is the command that allows you to insert a new driver code. So what I'll do is, I'll open the syslog, tail-f shows live logging of the events. I'll remove the driver code and then I'll insert the driver code. And then you can notice what happens, how my machine actually got the MAC address registered, how it got associated, authenticated, and how it got the IP. So you see, network unreachable, DHCP release fired, and now all my interfaces, whatever I created, are disabled. Now I'll say mode probe. So there are a lot of commands coming, but see, this is what is happening here. First of all, your ATL says that phi is now enabled and the rate control algorithm is fixed at minstrel_hd. Okay. After that, NL80211, so this was till ATH9K. Now here NL80211 gets fired and it says Wi-Fi device control is using NL80211, and here now it says that ATH9K has identified the device. After this was still MAC 80211, ATH9K and NL80211 and CFG80211. Now comes the role of network manager, and network manager was the one which shows what all Wi-Fi are available to you, and it says it is now disconnected. So I have actually taken snapshot of selected messages here. And now network manager, with network manager, WPA supplicant is running in the background and it says control event of scanning has started. So it has started discovering what are the networks available in my vicinity. After this, you see this need authentication. Network manager says I have found faculty staff to which I was earlier connected and this needs authentication. Do I have the key or not? If it has the key, it directly goes from inactive state to authenticating state. Are you able to see it? Now after this processes of authentication, send auth 2/3. Now WLAN 0 is authenticated. Once this is authenticated, it starts the association process. So all the Wi-Fi frames are being shared between client and access point when this procedure of association is going on. And once this is done, you see association response, it is successful and the client is now associated. This is your MAC layer association is done. Now comes the TCP layer and IP layer, where before TCP, IP will come and it will say that DHCP transaction should begin. We have DHC client which allows a device to get the IP address. DHC client started and IP address, I have removed the last two objects of my IP address. The address, you see address, gateway, name server and domain. Everything is now assigned to my machine. So this is a process that happens once your machine is on, irrespective of which device you are using. Maybe there are other ways to log on with other machines, but more or less you have a process of authentication, association, DHCP, and finally your device So if you are doing any controlled experiments, even if you don't have an IP address, you are still connected. You can actually communicate with the access point because you are connected over MAC. But there are other ways of communication because you don't have an IP. So this is another important file in the Linux subsystem proc/net, which has most of the information of your network devices. So if you say proc net wireless and just try to see it every second, you will be able to see link quality. On some machines, IW config might not be giving all the informations, right? So if you, I've actually sent this command in the watch, which is watching it every second, and I see interface WLAN 0. What is the link quality? How much is the noise coming, which is quite important when you are doing controlled experiments. What are the network packets? How many are sent? Beacons missed, and some more information depending upon the card that you have. So this is another important command. Next command is the device level information. How many bytes are sent? How many packets are sent? How many bytes are sent and received? So both transmission and reception. Everything is getting logged here. So even if you do not know any command, if you just look the output of these commands on your machine every second or whatever periodicity you want, you will be able to see all the connection stats available to you. Even if your any other application layer commands available in the App Store are not working. So if you want, you can fire these commands on your machine and see what is the output. Do I wait or proceed? Okay. So in an operating system, it is not as simple as from the application layer to the physical layer you have only one flow. We have two separate flows. One for transmission, one for reception, one for control, and one for data. Can I get an idea of how many of you are aware of these different flows in a machine? So this is the two important parts, data path and control path, and they are from the operating system's perspective. So I am sure you must have written some Java code or C code to send a file from one machine to other machine, right? So that is your data path, where you actually have system calls. You say open a socket, you give the IP address, give the socket number, then you have TCP, IP, network layer talking to each other, and then finally from net device code your data goes through. But what about MAC? Where is MAC coming into the picture? Which is where control path comes. All your algorithms of rate control, of CSMA CA comes here. Of bit rate reduction, all those things comes here. So this is where you are required to make changes for your code. And then finally the driver. For example, ATH98. So backports is the code which you need to download. They keep on updating the code. So backports is the code which has drivers for most of the devices. Atheros also, Broadcom also. So if you download the code, just see the code structure, find out the place where you need to modify, insert. It's a simple C coding. You do that and you can compile it. So I'll give you an idea of how backwards code structure is arranged. So NL80211 is in net wireless handlers, NL80211.c, and this main structure which carries data from NL to CFG is this structure, GNL ops NL80211. This is very important because it took me like few months to realize that which is that structure which is essentially carrying data across the layers. Okay. So this is NL80211. Then most of your device configuration, even creation of your virtual interfaces, if you want to create multiple virtual interfaces on your single physical card, if you are aware of MTTCP protocol, it can send data over multiple interfaces. CFG80211 is the layer for you. So you have, and the main structure which carries data is CFG80211_x.
It looks like a VFS struct here. Do a VFS
Yes, yes. And then you have MAC 80211. So it has all the code. If you have missed a beacon, maybe my device is about to lose a connection. So how many beacon misses before I decide that my connection is lost? This is MLME. authentication, association, reassociation, deauthentication, acknowledgement handling, probe request, power management. So MAC 802.11 is the, 90% of your changes are required in MAC 802.11 when you are trying to change anything from the device. Okay? And once you have all your virtual interfaces being built up, if that is your work area, then MAC 802.11 will have one stream for each of those interfaces, because those virtual interfaces will instantiate one MAC 802.11. Okay? So you don't need to worry. This is quite parallel in nature. You don't need to worry about my data going here and there. And then finally, you have ATH9K, which has all the transmit and receive functionality, which decides if I am ready to send a frame or I am not ready. Now, how is a packet received? ATH9K, there is main.c in ATH9K. It sends an interrupt to the hardware. Then it goes to receive.c. And from receive.c, all kinds of packet headers are reconstructed from the bits that have arrived, and from there it decides it should go up to the kernel or it should go back to the air. Now what does that mean? When does a packet will need go back to the air? Once I have received a packet. Any idea?
It is correct.
If it's serving as a if we're just transmitting it along to ensure that it doesn't lose any of its information. That is, we're just a node, we're not receiving it at the end.
So, okay, so you tell me, in wireless domain, when I am transmitting to someone, how would I know that I have transmitted it successfully or not?
Acknowledgement hash.
Acknowledgement. So acknowledgements are not sent to the higher layers. Acknowledgements are sent from your tribal layer because they are very time sensitive. You have to get acknowledgement after short interframe arrivals. Okay, which is the lowest. It is 10 microseconds for I think 802.11g. 10 microseconds is like nothing. So if it goes to the upper layer, acknowledgements will be delayed and the receiving end will think that my frame is lost. Which is why here, if the packet is successfully received, this device queue transmit will be called, that send to the air acknowledgement, my frame is successfully received. Okay. Now how is the packet transmitted? From the kernel to the air. Transmit.
So when the packet is received, it is usually decoded and then there is a RC check.
Yes.
And that's when the ACK is sent.
Yes.
So that will happen at the MAC layer. Is this inside the driver code or in the interrupt?
Sorry?
Does the ACK go in the interrupt routine or goes in the
No, it directly goes from ATH.
interrupt setting?
Does not need. It will go from firmware. So the next is how is packet transmitted from kernel to the interface. So I have specifically written it a virtual interface because every interface in Linux is a virtual interface. Setting aside this idea that you have one virtual interface or multiple virtual interfaces. But if you see WLAN 0, 1, 2, 3, all these are virtual interfaces, they are not your physical interfaces. And whatever virtual interface you will create, you will have multiple queues for them, which is what MPTCP is working on. So here you will have kernel to interface, tx.c, it will call sub interface, which is, see, all the driver codes are made for that only. They will call it a sub interface, which was a virtual interface there, and they say you start transmission. Now here 802.1_ops, this is the important structure which will carry the data. And in this main.c you have 10 transmission queues which are for ATH. And these 10 transmission queues, if you are actually monitoring, you will be getting to know that which of my queues are actually overloaded or not. Basically, when you are experimenting and your applications are generating too much data, in that sense, your data might be lost at the kernel queues. And you read this most of the time in papers. So what are those kernel queues? These are those queues. If you are able to increase their sizes, you will be able to save a lot of this thing. But the sizes are optimal enough and decided after a lot of temperatures. So it is not advisable to change with the size of these queues. but you still might want to put a tap on these queues and see how your data transmission is going on. And finally, mac.c will say 8890 hardware transmission starts. And then it writes a register in your physical layer before the hardware begins the transmission. Now, how do you debug the code? So you can actually say, first of all, you need to make menu config. We have a link here. I don't think it is visible, but you can take the slide deck. I have given the link where it says that how you have to do the debugging, you have to enable the debugging. So you say make menu config and you enable all kinds of debug options there. So once you have done that, I showed you a demo of mode probe 8890. So there if I say debug is equal to 0 FFFF, which means I want to debug everything possible. Tail minus F. So you just saw that when I started tail minus F syslog, there were hell lot of messages coming. By default, those messages are not enabled. Because I have enabled my module in debug state, I was able to see all this thing. You will be even able to see when is the interrupt routine called. It also logs that. Okay, so it gives you very, very precise pointers to put a tap on so that you know when what is happening when a packet is being sent from application there. And then for Mac, it's little different, Mac or CFG, because it is the bridge of your kernel and the application there. So you mode probe in a similar way with debug flag, but you need to trace Mac features because that is basically the management entity and it is quite time sensitive. So this is the command, trace command. You say record -e and Mac 80211. If you want to record Mac 80211, you say record Mac, or if you want to record CFG 80211, you say record CFG 80211. And then it will start recording. And until or unless you stop it, it will keep on continuing. So once you stop it, you will have a file named trace.dat created in the folder where you initiated that command. So you can, and trace command is the same command which will allow you to analyze because it's not readable otherwise. So you see generate a report based on the file that it just wrote. So I have given this an example of grep scan because a lot of information is being recorded and we cannot, as humans, we cannot read all of that. So let's say if I just wanted to analyze what is the scanning procedure going on, how frames are exchanged. So I just say grep scan, so it will give me all the pointers when scanning was initiated and how it was completed from the Mac. Okay, so I will give a demo of this debugging of Mac here. So I'm saying you mode probe, one second, you also need to remove Mac. You see, it is telling me all the dependencies here. Now I've removed everything and now I can remove Mac 80211. Okay. Now I say mode probe Mac 80211 with debug. So now my driver is up here. You see, it has started establishing the connection. So this has started recording. Now I will deliberately initiate scanning because I don't know if it is doing in the background or not. recording is done. I got the result of all the Wi-Fi networks available to me, and I will stop the recording here. And now I will say what Mac has actually recorded. You see, driver software scan complete, which is one of the functions which is called, it is actually a function which goes from CFG to the lower layers. Software scan, I'm sure this scan complete was an older one. I initiated scan from IW, and this is a K worker, which is a kernel queue. So this must be initiated by network manager once it established the connection. Okay, and this one is mine. I said driver software scan start. File 9 is the physical, the ID of the physical card, and the virtual interface is W0. So whichever interface card was used to initiate the scan or whatever communication, that is actually logged here. And then finally, when the software scan was complete, kernel reported it back to the application layer that it is completed. So it started from the application layer with IW, and it came back from the kernel K worker. Okay. So now this is the next thing, that what frames I am recording, can I get much more detailed overview. So once you have enabled debug options of your ATH9K, your kernel will have a directory created with debug, with the name of debug, and in that debug you will have IEEE 802.11. And because I have 5.4 and ATH9K, if you do a cat of receive file there every 1 second, so I think 1 second is a good cardinality. So you will be able to see how many packets are sent, how many bytes, how many beacons. Now, why beacons are very important? Because there are two kinds of scanning available. One is active scanning and another is passive scanning. So the demo which I just now showed you was an active scan where I deliberately sent probe requests and got the probe responses. But for client who does not want to do an active scan and still wants to know if my access point is still alive or not, so you have beacons which are announced typically every 103 milliseconds, which are recorded by every client by passive scanning. Okay, so which is why beacons are very, very important for Mac server management entity to basically track if your access point is alive or dead, even if it does not do active scanning. Okay, which is why every wireless card takes care of these beacons, and it records how many beacons are received. All your CRC errors, all your post-delivery CRC errors, so all sorts of information is available depending upon your need, you can actually go through. Similarly for transmit. So you see for transmission you have 4 queues here. So now we do not have data which is a simple data frame. We have 4 different types of queues available with us, which is best effort, background, voice and video, to enable the quality of service in our network. So and when the data is being generated from your application layer till the physical layer, you have 4 different queues created here, and in those queues you can see where my data is going. And MPDUs, AMPDUs, these are all concepts of your 802.11n, aggregated, non-aggregated, all those things, they are actually recorded in this particular thing. So they will not be available until you enable debug options in your driver. Now these are some important commands. Sudo IW event -t. Even if you do not modify anything and you still want to see what my driver code is essentially doing, you fire this command. So I'll show a brief demo here. So right now nothing is happening, I'll just disconnect it. Scan started, deauthentication disconnected. And by default scanning has started. And now I'll say connect again. But it will only show me wireless related events, it will not show me if DHCP is fired or not. So now it is again authentication, association and connect. Okay. Similarly, dmessage is another command, and the rest of the commands are mostly shown. So these are important URLs because slide deck will be available to you. You can actually take a look at all those commands. You can download backpost driver code here. Just open up the code and do all kinds of modifications whichever you want to do. Where exactly you want to modify, those locations are also available in the slide deck I showed in the beginning. NLA 2211, CFG and MAC. That's all. So I tried to be as brief as possible because going deeper into driver code will make it very boring. I tried to give an important pointers which are required for any developer to begin with. Okay? And all the URLs are available. Once you have the relevant background, it is very easy to go to the URL and find out the information, find out the code, because you know now where exactly code modification is to be made and how you can do it. That's it. Thank you. Questions?
What is packet injection? Because we have like beacons mode and there is monitor mode and there is another packet injection.
So in that you artificially generate packets and send them. So there are softwares available for that. You can generate
Like
packets.
air
Exactly.
Yeah.
Why is it that some cards allow monitor mode and
Some cards don't allow. It depends. I think it is manufacturer dependent. So as open source community, I think Atheros is the best one to.
I think it is related to hardware implementation.
Yeah, possibly.
If you use AirTrack, then you have to like scan all the networks around you. So and you have to put your card into monitor mode.
Yes.
So does that monitor mode come included with this driver and AirTrack
Yes.
is
So
next to use it, or is it built into
AirTrack will be able to work only if your card supports that monitor mode. If it does not support, it cannot. So in the beginning I showed a command IW list. With that you can check if your card supports that or not. Okay, so you will have to do that, right? If you want, I can show you a demo of how a monitor mode is created and how you can capture that. But do you want me to show that? And the good thing about monitor mode is it listens passively. So it won't inject anything and it will silently sit on top of your main card. You can still continue to communicate. At the same time, you can still continue to capture traffic of the nearby channels. So sudo, you can take a note of this command.
But can it be associated with an AP?
Yes. So I'll show you. I'm associated. So sudo iw dev wlan 0 is my main interface here. Add mon 0 type monitor. So it created. So I'll have to bring it up with if config mon 0 up. And then I say sudo varasham. So I have mon 0 here. And I start recording. So all the Mac layer frames have started recording on the machine.
So here you created a new virtual interface.
I created a new virtual interface whose mode is monitor.
So if you go in the options here, like in the Wifi, there is usually an option to just go into monitor mode on your double
That is different. That doesn't work. It won't give you
because
this.
if you use Wireshark, you can still use your NIC to connect to the net. But if you use AirTrack, then you're disconnected. You can only listen.
That's basically how AirTrack has been this thing, but I mean it's that application dependent.
So there's no functional difference. You still get the same frames.
You should get it. So you need to basically, when you are enabling monitor mode, you are listening from channel number 1 to channel number, let's say 12 in round robin fashion. Okay, for time slicing manner. If you enable a particular channel on which you want to listen to, right, then you say that you actually fix that channel and you listen on that channel only. AirTrack gives you many options. That is how their application is being done. I mean, whatever option you enable there.
I mean, actually, how do they do it? Is it like whenever a packet comes to my and I see, it just checks. If it's not for me, I'll drop it. So
That is the default behavior.
that's the default behavior.
Yes.
So when I
But
make it in
monitor
promises
mode,
it tells you, okay, take it.
Yes, yes.
So
You
that
take whatever is
exactly
coming
what
to
I'm
you.
saying. Is that?
Yeah. So basically, even if I enable listening only on channel number 6, it will listen on -5 and +5 because that is due to overlapping. Right? So you cannot be sure that whatever I am actually capturing is only on this particular channel or not. So only so the easiest way how I differentiate it with the sequence number, and I listen on all the channels like channel number 6, 1 and 11, and then I see what are the sequence numbers. Or other one option is you change the driver code and log all the sequence numbers generated, and then you can match that what sequence number was sent on which channel, because that I can log with the driver code. I just need to write a debug statement, decompile and reinsert the module.
So, back to my original question, so what is the difference between the monitor mode that Wireshark or Subsystem is offering and creating a virtual interface, and then, just creating a virtual interface in monitor mode? Like, what's the difference between these two things?
What kind of data you get there? What kind of traffic you get there? When you say Wireshark in promiscuous mode.
No, not just promiscuous. So, Wireshark also gives an option to run in monitor
It
mode.
does give an option, but how many times does it work? I have not seen it working in the expected manner.
Okay, yeah, so that's what I'm asking. Like,
Yeah. So I have not opened up the code of Wireshark, so I cannot comment on that, but I have not seen it working. So best option is take an atheroscard, enable monitor mode, and it's easy.
I worked on it, I think it also works for it.
yeah,
If
so,
you put it on monitor mode, assign a channel to it, it will make all the data.
Any more questions? No? Shall we end? Coffee biscuits over? Thank you. So slides will be available. My first name is Dheryta.